We start with malting barley. It is germinated, and the reason you have to germinate it is because in that process you will synthesize the enzymes that are necessary to convert the endosperm, the starchy endosperm, into a usable form. So what happens is when the grain becomes hydrated, the embryo starts to synthesize hormones, gibberellin, for example, abscisic acid, and they migrate to a tissue in the grain called the allurone, which once it's hydrated and sees these hormones, it responds by synthesizing enzymes. And these enzymes diffuse following the water into the starchy endosperm. The first ones basically loosen and open up the cell wall, and then you have the enzymes that solubilize and start to digest the protein, and then last of all the enzymes that, particularly the enzymes that develop to hydrolyze the starch. Of course, in the malting process we don't want to lose starch. We want to keep that because that's our potential extract. So there's a balance, and this is the art. There's a lot of science, but this is the art as well. So you'll probably germinate for about 4 days, and as the grain has its cell walls and its proteins degraded, so it gets softer and more millable. And then the last thing you do in the malt house is to dry it. You start off the drying at a fairly low temperature because the enzymes are kind of heat sensitive. When the water content starts to come down, the grain is drier. Now the temperature will start to rise, and you will actually raise the air on temperature. And so you produce a range of malts. If you produce fairly lightly dried malts, they'll have a very high enzyme level. But also they have a very pale colour and a light flavour, because in the kilning process, amino acids produced in the germination and sugars produced in the germination, particularly from the cell walls and some of the starch, they react together to form Maillard reaction products, melanoidins and so on. And so you get the development of flavour and colour. So the more intensely you heat it, the more colour, the more flavour. So you store the malt, then it's milled, it's ground up into a powder, so you get good access when you add the water. So you add the water. You might start at a relatively low temperature, about 45 Celsius, to complete the breakdown of the cell walls, because those enzymes that break the cell walls down are very sensitive to heat. But then you raise the temperature to conversion temperature, as we call it, and that temperature is where you need to deal with the starch. Now the reason the starch is not particularly well broken down in germination is because it's in the form of granules, which are kind of tough and difficult to break down. In the mash, in the brew house with the mash, what you're doing is gelatinizing the starch, and different starches from different cereals need different temperatures. For barley, the starch pretty much should be fully gelatinized at something like 65 degrees Celsius. So that is the magic and the historic conversion temperature. And at that temperature, the starch-creating enzymes last long enough to break most of it down to fermentable carbohydrate, particularly maltose, but leaving behind again about 20% of what is called these limit dextrins. And that's because one of the enzymes, starch-creating enzymes, is inhibited, it's blocked, and doesn't act very much. An enzyme called limit dextrinase. So after about an hour or so, then you will start to separate the liquid from the spent grains. That's called lautering. And there's various ways of doing that. And you collect this liquid called wort, and you boil it, and you clarify the wort to get rid of proteins and other things that are precipitated in the boil. And then you cool, and you ferment. And you put in either an ale yeast, Saccharomyces cerevisiae, which, given its druthers, will rise to the top of the fermentation, or a lager yeast, Saccharomyces pastorianus, which will sink to the bottom of the fermenter. Condition the beer for various lengths of time, depending on your passion. And of course, after fermentation, it is customary to drop the temperature down. And one of the consequences of dropping the temperature down, classically to -1 degree Celsius, centigrade, is to chill out more protein and material, which otherwise will give you turbidity of the finished beer. and that's called cold conditioning. You basically will filter it and stabilize it. You could use things like silica hydrogels to bind proteins, age-sensitive proteins, and things like polyvinyl polypyrrolidone to bind polyphenols. And then you will, chances are, you'll top up the carbon dioxide, and then you'll stick it in a bottle. Because it looks like he's nailed the whole thing. You don't find too much sexy equipment in my lab. I said to them, I said, any of these would be sold all over the world. And I said, you wouldn't have sold any if it wasn't for me, so how about giving me one? So this is how I do business. I insult people. In Berlin they call me the Pope of Foam. This is the most popular class on campus, having pushed sex into second place.